Welcome, this is Coach Dorf. We're in section 2.8. We're going to look at the following homework-like example. So in this problem, we're given in the top right-hand part here, we're given the graph of a function that's colored in red there. So there's the graph of a function. And what we're supposed to do is use this graph to sketch the graph of its derivative. All right, to do this problem, I went ahead and I replicated that original graph down in the bottom left-hand side. And then below that graph of the original function, I just put a grid part so that I can now sketch the graph of its derivative in that part. In doing this, the important thing to remember is that the derivative equals the slope of the tangent line. Now, this isn't the only way to think of derivative, but this is one way to think of it. It's the slope of the tangent line. So if I had a curve that looked like this, and if I were to take a point here, then the slope of the tangent line there, that slope equals the derivative at that point right there. So we're going to use that idea to sketch the graph here. So let's start with our red graph. We're going to start on the far left side. So what do I notice about if I were to draw a tangent line? So tangent line is going to look like this in blue on the red. Well, what's the slope of that blue line? Well, it's negative. It's going down. And so I should have a negative value somewhere around in the graph below. If I went further to the left here, what happens to the tangent line? Well, it's getting closer and closer to zero. So my curve over here is getting closer and closer to zero, but it's still negative. All right, let's keep going. What if I take on the red curve, if I'm about here, it's more negative. So I'm going down further negative, but eventually I get to this part here, and I notice that my tangent line is horizontal. It's flat, and that means the slope is zero. So at that point, I'm back up to zero here. If I were to try to connect all these together right now, I'll do that in blue. This is going to look something like this. All right. So this is going to represent the graph of the derivative. Let's go back to the red line now. What do I notice after I pass? I've got that orange part where it's a horizontal tangent line. Now, what happens when I go past there? Well, if I'm at a point like this, the tangent line, the slope of that tangent line is positive. It's going up. So I'm going to have to be in my graph of the derivative, I'm going to have to be above the x-axis because those are where the positive values are. So I'm going to be above the x-axis for these values and probably at a point something like in the middle right here. So I'm going to have the max positive slope. And that's going to probably happen where x is 0 in the red graph. So somewhere up there, I'm going to get the highest value. So my graph is going to continue to look like this, something like that. But then after that, on the red curve, after that blue tangent line that we just shown in, let me draw a green one. Now what happens? Well, my tangent line becomes less positive. So it's going to be going back down. It's still above the x-axis in the graph of the blue line, in the graph of the derivative, because it's above the x-axis, so it's positive, because the slope of that green line that we just drew is still positive. When I get to here, what happens? Well, then the slope of that orange line is 0. So I'm going to have to go back, and it's going to be 0 again. So if I were to draw in more of my graph of my derivative, it's going to look something like this. And now what happens when I go back to the red line? After that last orange horizontal line, if I draw in a tangent line here, what's the slope of that purple one? Well, it's negative. And if I draw in some more lines, it's negative. It's still going down, but it's going down, getting closer and closer to 0. So what I'm going to have here is my purple dot is going to be negative here, and then I'm going to get a green dot that's going to be negative, but it's going to be getting closer to 0. And if I connect these, then it's going to look something like this. All right. And so the original red line we had was the graph of a function f, and the graph of its derivative looks like what we drew in the blue line. And the idea here was to use the fact that the derivative can be represented, can mean the slope of the tangent line of a curve at a point. Hope that helps.